Today we are going to be doing coordinate geometry questions. So using those cheat things that we came up with last week and actually applying them into questions. So hopefully I have managed to budget my number of marks and my time available correctly. We'll see how we go. Okay, so I hear we've got more people in. Brilliant, we're filling up fast now. That's the thing, you know what? As soon as you start, then everybody appears. Okay, right. So let us then revisit, because I'm not quite sure if you guys were in the very beginning. So we are doing coordinate geometry again today. This is part 2. So last week we developed the cheat sheet, looking at all the different things that we've got to use. This week we're actually going to be using that cheat sheet, using all our different approaches and our formulas to actually do some past paper questions. So I've set it up with lines. Now we have to see if the lines on my page are going to fit my handwriting and how it's going to work. But I wanted you guys to see one of the things is skipping lines when you do different things. And if I just write on a blank screen, then you have the excuse of, I didn't see that. So no excuses. So let's have a look at this first question. This is Winter 12, Paper 12, question 5, if you like to note that sort of thing. We are looking at a diagram with a triangle ABC. A has coordinates 1, 3, B has coordinates 5, 11, and ABC is 90. So the point X, 4, 4 lies on AC, and they want us to find both the equation of BC and the coordinates of C. So first thing we need to do is to actually think about what have we got, what do we need at the end, and how are we going to get from here to there. So equation of BC, remember we're using our y minus y1 equals m, x minus x1. So we need a gradient and we need coordinates. So equation of BC. Well, we can see straight out that coords we're happy because we've got 5, 11. Okay, gradient, we don't have. We're not told the gradient of BC, and we've only got 1 point on the line. So we have to think a bit more. Okay, so what do we have? We have a happy relationship. Okay, we have a perpendicular relationship, which means we have m1, m2 equals minus 1, and we're perpendicular to AB, and on AB we have 2 points. So we can actually calculate the gradient and work through. So while we're in this planning phase, we can plan for the next piece of the question as well. Coordinates of C. Yo, C is out in the middle of nowhere. Okay, and in this case we don't have a rectangle or a square or something fun like that where we can do a vector step. So the only way to get our coordinates here is simultaneous equations. Okay, what do we want? We want BC and AC. Funnily enough, they're getting us to do BC in part 1. Part 2, we would need to get AC. Ooh, we're lucky here. 1.2 points, 1 point and a gradient. We're good to go. So we can get BC, we can get AC, we can get C. And now we're happy to actually start the question. So, we are going to start with the equation of BC. We said we're first going to work through the gradient of AP. So, we tell our examiner what we are doing before we actually do it. Okay, so for gradient of AB, MAB, little m for gradient, remember? Y change over X change. So 11 minus 3 over 5 minus 1. So gradient AB equals 11 minus 3 gives us 8, 5 minus 1 gives us 4. So MAB equals 2. Right, so now we're actually ready. We have that all-important information about our gradient, and we have our point. So we can now go for equation of BC. We have a point. I think it was 511, yes. And we have MBC equals -1/2. And we don't just leave it at that. We write there M1, M2 equals -1 for perpendicular lines. Okay, so the idea is we're never just randomly doing anything. We're communicating our method the whole way through. So BC, now we have y minus y1 equals mx minus x1. So now we simplify 2y minus 22, I don't like those fractions, minus x plus 5. 2y equals minus x plus 27, I believe. Shout if I do go squonk. So now we have an equation for BC. They did not tell us in a certain format. So if we tidy up, we could say 2y plus x minus 27 equals 0, but it doesn't really matter because actually that's a bit back to front, isn't it? We were being a bit legal about this. We would go px, so x plus 2y minus 27 equals 0. This is our standard non-fraction format. But the thing is, because they didn't tell us, they're not marking us wrong or right as long as our line equation is correct, so then we've got our marks. The thing that you're thinking of is, what am I doing next? And next we're going to be doing simultaneous equations. So bear that in mind in terms of how you leave your final answer for part 1. So for part 2, to be good students, we'll label this part 1. So for part 2, we said we've got BC now. We need AC in order to be able to do our simultaneous equations. So we've got a point, we're happy. No need to figure that one out. We need a gradient. So for gradient of AC, it's 4 minus 3 and then minus 1. So 4 minus 3 over 4 minus 1. Did I get those the right way around? I did. Okay, so this equals 4 minus 3 gives us 1. 4 minus 1 gives us 3. So gradient of AC is 1/3. So now we can do for equation of AC, we can take a point, 1, 3. We can take MAC equals 1/3, and we do exactly the same formula. Y minus 3 equals 1/3 x minus 1. And again, I say to you, always use this. This is how you build a line. You have to use this formula. Okay, get rid of our fractions first out. 3y minus 9 equals x minus 1. So 3y equals x plus 8, I believe. Okay, so I don't have the answers written down here beside me. So if I do make a mistake, it is possible. So shout if you see something. Okay, so we have BC from part 1. We have AC from part 2. So now they both meet at C. So if we solve them simultaneously, we get our point C. So tell them again. For point C, we have BC equals x plus 2y minus 27 equals 0. And AC, ooh, bad teacher. No more than 1 equals on a line. BC colon, AC colon, 3y equals x plus 8. When you start getting multiple equal signs on a line, then it's so easy to get distracted and get confused. So it's not BC equals, it's BC. This is the label of the BC line. So colons, much happier. Right. So simultaneous equations, our x's are standing on their own. So let's turn this one into 3y minus 8 equals x. And then we can go 3y minus 8 plus 2y minus 27 equals 0. So 3y plus 2y gives us 5y. Minus 8 minus 27 is a minus, and it's a plus, and it takes us to 35, I believe, equals 0. So 5y equals 35, and y equals 7. We then go back to that one that we rearranged, because why would we want to use one of these ugly ones? We know that x equals 3 times 7 minus 8. So x equals 3 times 7 is 21. 21 minus 8 is 13. Any guesses as to the fact that I didn't bring my calculator to class today? So C is 13.7. Then we go back to our diagram. Okay, our diagram is not to scale, but does 13.7 make sense? 13, yeah, it's way up on the X. 7, yeah, it's between 4 and 11. So it's not exact, it's not something we can measure, but if, for example, we'd gotten our coordinate back to front and written 7, 13, then we'd be saying, oh, hold on, C can't be 13 if B is 11. So it's just that level of double checking your answer to make sure that you are happy with it. All right, so there we go. So we've used gradient, we've used formula for equation of a line, we've used gradient calculations, we've used perpendicular gradient, we've used intersection. So all of these things are coming off our cheat sheet from last time. So let's have a look at another question. This question is also a diagram question. When it comes to lines, they like diagram questions. Here we have a rectangle ABCD with the points A3, 2, and B1, 6. And you should be frowning because there's a feature you know about rectangles that's not on this diagram. Rectangles have right angles. So put them in. Because when you see right angles, you're triggering perpendicular gradients. So that is why they've left them off. Because they don't want to trigger that perpendicular gradient. They want you to think. So if you see, and it says rectangle, then we've got 90-degree angles. So questions say, find the equation of BC. Right, okay, well, we've got a point, we've got a gradient relationship. See, we're getting a pattern here. They're not telling us gradient, they're giving us gradient relationships. Then, given that the equation of AC is y equals x minus 1, find the coordinates of C and the perimeter of the rectangle ABCD. So, equation of BC is going to give us this line. AC is going to give us this line. Oh, magic! We've got almost the same question here. Intersecting at C. That's going to give us the coordinates of C. Perimeter of the rectangle ABCD. Well, perimeter is all about lengths. So we would need the length of AB, we would need the length of BC, and we can just double and add. Once we've got C, we can get BC. We can already get AB. Okay, so we're happy with the skills that we need to use on this. We can go ahead and do him. So, find the equation of BC. We start in exactly the same place as last time for the gradient AB. MAB equals 6 minus 2 over 1 minus 3. So 6 minus 2 gives us 4. 1 minus 3 gives us minus 2, giving us an answer of minus 2. Right, so that's our gradient of AB. We have a point, we can get a gradient relationship. So for equation BC. Oh, and I didn't even point it out to you. Here I skipped a line, right? Because I was changing from one thing to another. Every time you change from one thing to another, you skip a line. Same like writing paragraphs in English. You have a paragraph about breakfast, a paragraph about lunch, and a paragraph about dinner. You wouldn't make it all one long paragraph. So use that same skill in maths. Remember that you're communicating. You're not just solving sums. Okay. So equation BC, we need our 0.16. We need our MBC equals, in this case now, a half. Same reason. M1, M2 equals, am I drawing equal signs? 4 perpendicular lines. Okay, we're always giving that justification. Right, then we can use our equation, and we skip a line again because this was our sort of summary getting us ready. Then we do y minus 6 equals a half x minus 1. Oh, that's another point. Why do I do that summary? Okay, it's because there's lots of information in the question. So I want to be sure before I start plugging into a formula, this is the information that I'm going to be using. Okay, so it helps sort of calm the brain down. So 2y minus 12 equals x minus 1. 2y equals x plus 12 minus 1 is 11. Okay, right. We have the equation of BC. Brilliant. So now we need part 2, coordinates of C. BC and AC both have C in them, which means that BC and AC intersect at C because they both go through C, which means simultaneous equations. Okay, so this is another one of those things that if we had more information, we could have used vector step. For example, once we got C, we can get D from a vector step. But there is nothing vectorish that gets us from AB all the way up to C. So we need that simultaneous equations in this case. So BC is 2y equals x plus 11. And AC is y equals x minus 1. So in this case, it's x who's on its own again. We always want to keep our life as simple as possible. So y plus 1 equals x. And then 4 coords of C. And I don't mind you writing 4 coords. I mean, at the end of the day, this is a notes that are helping you structure your answers. You're not getting marked on, did you spell coordinates right? Okay, don't tell your English teacher that. So, always, 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 our favorite formula, y minus, what am I doing? Sorry, I'm getting distracted. For coordinates of C, we are now doing simultaneous equations. So 2y equals, our x is now a y plus 1 plus 11. Another note to the y's, always substitute using brackets. Take care of your signs while you have them. 2y equals y plus 12. So, very nice and simple this one, y equals 12. And then x equals 12 plus 1. So x equals 13. So C is the coordinate 13, 12. Same story as last time. Back to the diagram. Does 13, 12 make sense? And it does. So we're happy. Okay, so we have the coordinate C. We want the perimeter of A, B, C, D. So A is 3, 2. B is 1, 6. C is 13, 12. Okay? And I'm just going to do this here to keep track because I hate scrolling backwards and forwards. I am right, aren't I? A, B, C, yes. So, we want double AB and double BC, and we add those two answers together will give us the perimeter, the outside edge. So, AB equals, distance formula should be a good friend, square root of 3 minus 1 all squared plus 2 minus 6 all squared, which equals a square root of 3 minus 1 is 2. 2 squared is 4. 2 minus 6 is minus 4. Minus 4 all squared is 16. So square root of 20, which is 4 times 5, which is 2 root 5. And I think I didn't give myself enough space. So we're going to do something illegal. And we're going to pretend you're not watching this. BC equals. Okay, the reason it's illegal is we're working left and right. You always want to work down your page. So BC is 13 minus 1 all squared plus 12 minus 6 all squared. So square root, this is 12 squared, which is 144, plus 6 squared is 36, which is 144, 150, square root of 180. Oh, goodness gracious me. I know that simplifies. 180 divided by 5. What does that get us? $36. Brilliant. So, we disagree. Let me double check. 180 divided by 5 equals, okay, 36. Luke and Bruce, please double check yours. Okay, so the reason I divided by 5, because I'm looking for that root 5, because chances are I'm going to have the same kind of surd as I had for AB. Okay, so we now know we need the perimeter. Ooh, if you can even spell perimeter, it helps. No problem. Okay, perimeter equals 2 times 2 root 5 plus 2 times 6 root 5, which is 4 root 5 plus 12 root 5, which is 16 root 5. And we leave it like that. Okay, so remember we want to keep our accuracy. That's why we actually learn about using surds and using surds. So if they asked us to give our perimeter 3 significant figures, let's double check. They didn't. They just asked for the perimeter. Then we leave it in that surd format. Okie dokie. Right. So we've now added length. There is one little thing in your toolbox that we haven't used yet. And here he comes. Okay, 6 minutes to do 5 marks. What units? Oh, sorry, units. It would just be 16 root 5 units because we're working off a graph. So we don't have centimeters, millimeters, and all of that nonsense. We would have units and unit squared or squared units. Okay, right. So the little friend who has been missing from our cheat sheet in terms of this lesson is your midpoint. And this is the type of question where midpoint rises and shines. Perpendicular bisector. Okay, sorry, reading the question. Find the coordinates of the point at which the perpendicular bisector of the line joining 2, 7, 2, 10, 3 meets the x-axis. Perpendicular, he's triggering radiant. Bisector means directly, exactly, precisely in half. So, midpoint. So, we have a whole lot of words here. So the best thing to do, I think, is to turn this into a whole lot of sketch. Not something beautiful. 2, 7. So a little bit over and a lot up. 2, 7. 10, 3. A lot over, a little bit up. Okay, the line joining them goes through here. Perpendicular bisector goes through here. That's the midpoint. And where does it meet the x-axis? This is at x and 0 because our y-coordinate is 0. So we've got a few things, but now it's a little bit easier to see what we're aiming for and everything once we have our sketch. We need to get the equation of that perpendicular bisector before we can set y to 0 and solve for x. So to get the equation of a bisector, we need a point and we need a gradient. See, we're using that y minus y1 equals mx minus x1 over and over and over again. It's your best friend. Our point. Neither 2, 7 nor 10, 3 will work because they're the ends. Our point is going to be the midpoint. But we have a formula for that, so we're all good. Gradient, we are perpendicular to the given coords. Okay. So let's call these A and B for making life easier. And if you want to do something like this, make sure that you indicate in your answer. A is 2, 7, B is 10, 3. There's nothing wrong with inventing letters when there are no letters given, but make it clear to your examiner what your letters mean. Don't just randomly chuck letters at them and expect them to follow. So we want the midpoint. Okay, this is going to be for point on our line. We want midpoint AB, capital M for midpoint, equals 2 plus 10 over 2, 7 plus 3 over 2. And remember, we're doing a coordinate calculation. So we put in our brackets and put in our comma from the beginning. So midpoint of AB, 2 plus 10 is 12 divided by 2 is 6. 7 plus 3 is 10 divided by 2 is 5. We have our point. So for gradient of who's using AB? Let's do that. MAB equals, so y change over x change, 7 minus 3 over 2 minus 10. 7 minus 3 gives us 4. 2 minus 10 gives us minus 8, which is minus a half. So now we're doing for equation perpendicular bisector, because we've got everything we need. We have our point, 6, 5. We have our gradient equals 2, because M1, M2 equals minus 1 for perpendicular lines. Right, our friendly formula, y minus 5 equals 2, x minus 6. So y minus 5 equals 2x minus 12, y equals 2x plus the 5, 12 minus 5 is 7. So we now have the equation of the bisector, but they want to know where does it meet the x-axis. So meets the x-axis at y equals 0. So 0 equals 2x minus 7. 7 over 2 equals x. So we have the point 7 over 2, 0. Finished. Barely breathing, but we got through all the questions, and I will give myself more space to write on next time.